Hello everyone, welcome to this video on nomenclature of ethers and esters. We will learn about the IUPAC rules for naming these two organic compounds. So let's get started with this. An ether is an organic molecule in which two alkyl groups are attached to an oxygen atom on its either sides. The system for IUPAC nomenclature of an ether is alkoxy-alkane, where the shorter of the alkyne chains will be named as alkoxy and the one which is longer in chain length will be treated as parent chain, and this chain will be named as an alkane. So we will combine these two together to get the complete IUPAC name of an ether. Let us understand this with the help of some examples. Let us begin with this example in which we have two alkyl groups attached on either side of an oxygen atom. We will select the shorter of these two chains and we will name this as per the rule an alkoxy group. There are two carbon atoms in this chain, so it will be named as ethoxy. While the chain having more number of carbon atoms in it will be named as an alkane. There are three carbon atoms, so it will be named as propane. To write the IUPAC name of ether, we will combine these two names and write them together as ethoxypropane. So this will be the IUPAC name of this particular ether. With this rule, let us move on to our next example. Again, we will select the one which is shorter in length along with oxygen and call this an alkoxy. There are two carbon atoms again, it is an ethoxy. And now there are three carbon atoms on the longer chain. We can number the carbon atoms present in this chain, and then this alkoxy group will have a definite position. At this point, please note that just like halogens, an alkoxy is also treated as a substituent. Okay, so we will have to number it from that direction which gives it a lower position. In this example, numbering either way will give it a position of 2. Okay, so the final IUPAC name of this ether will be 2-ethoxypropane. We have an ethoxy group on the second position of a propane. Okay, so hence onwards we will use these two sets of rules for naming ethers. Let us conclude our discussion on ether with this example in which we have bring another substituent methyl along with the methoxy group right here. We already noted that an alkoxy group is also treated as a substituent. So both methyl and this alkoxy, that is methoxy in this case, will be treated as substituent, and we will name this entire molecule same as we did for an alkane. We will find the longest carbon chain, that is of 3 carbon atoms in this example. We will write the name of the substituent along with their position. So both methyl and methoxy have the position number 2 here. So we will complete its naming as 2-methoxy 2-methyl propane. Once we have learnt about ethers, now let us get familiar with the IUPAC rules for naming an ester. An ester is an organic molecule in which the carbonyl group, that is carbon bonded with oxygen in a double bond, is linked with an alkyl group on one side and an alkoxy group on the other side. The IUPAC system for naming an ester is alkyl alkanoate, where the carbon chain which is linked to the oxygen is called the alkyl, and the entire chain including the carbon atom of carbonyl group along with the alkyl group is called as alkanoate. Let us do some examples for naming an ester. The entire ester molecule can be broken down into two parts, the one which is attached with the carbonyl group and the other which is attached to the oxygen. So, as per the rules, we will name this chain, carbon chain, as the alkyl, and we will name this chain that is linked with carbonyl group as alkane, and we will add the suffix oate. Okay, so the entire name will be alkyl alkanoate. There are two carbon atoms, so its name will be ethyl. There are three carbon atoms in the carbon chain that is linked to the carbonyl group, so its name will be propane, and for ester we will add oate, so the entire name will be ethyl propane oate. Okay, ethyl propanoate. Now let us bring a substituent on one of the carbon chains. In that case, we will have to write the position of the substituent as well. So, in case of ester, if we have to start numbering, then we will start in both directions. Okay, the group which is attached to the oxygen atom will be numbered starting from the carbon atom which is attached to oxygen. So this carbon atom will be given the position first, and then we will go on numbering and find out the longest carbon chain. So there will be a chain length of two carbon atoms in this example, and this group will be treated as a substituent. This is a methyl group. Okay, and on the left of the molecule, starting from the carbonyl carbon, we will number it from this particular carbon 1 2 3 and 4. Okay, if we need to number the portion that is attached to the carbonyl carbon, we will always start from the carbon atom of the functional group. Okay, so the alkyl group right here will be named as 1-methyl ethyl, and there are 4 carbon atoms on the left side of the ester molecule. It will be named as butane. For ester we will add OAte, butanoate. So the entire name will be 1-methyl ethyl butanoate. Let us see a similar example in which we have bring another substituent on both side of the group, both side of the ester molecule. So we will start numbering in the alkyl group from this carbon atom 1 and 2, and the substituent is here chlorine. Okay, and we know its IUPAC name as chloro. We will start numbering from this carbon atom here 1 2 and 3. On the second position of this chain, the substituent is methyl. Now you can yourself figure out the entire name of this ester. It will be named as 1-chloroethyl 2-methyl propanoate. So these are some of the important points that we have learnt in this video. The name of an ether group is alkoxyalkane. An alkoxy group will always be treated as a substituent. The name of an ester group is alkyl alkanoate. In our upcoming videos, we will be seeing the IUPAC nomenclature for naming aldehydes and ketones. So please do watch that video as well. Thank you so much for watching. See you in the next video.